Hi, I'm Vernji from VedicMathForKids.wordpress.com. It's been a while since I recorded an actual tutorial, but whatever. Today's tutorial it's more of a general lesson for something that you need to know as I get into more advanced stuff. So this is called finding the tens complement of a number. So there's no traditional comparison for it. So the tens complement of a number, if you have the number 89. Ugh, this marker's crap. If you have the number 89, then the closest power of 10 to 89 is 100. Now what happens when I subtract these two? I get 11. That's the tens complement of 89. 11. It's the distance from a number to the closest power of 100. Now, that was simple, but what if I have a larger number? Say, I don't know, 10,263. And I want to find the tens complement of that. Well, it's not that easy to subtract that from 100,000, which is the next largest power of 10. What if I want to find the tens complement of 10,263? And you may think, hey, he said that the tens complement was the closest power of 10, so it should be 263. Well, that's not quite right. See, the tens complement is the next largest power of the distance to the next largest power of 100. Yeah, it's how far below this number is below the next highest power of the next higher power of 10. So the next higher power of 10 for this is 100,000, and subtracting this from 100,000 is going to take too much time. So there's an easier way to do it. So now, first you subtract all but the rightmost digit from 9. So just gonna put 9999 here, and so what you want to do is subtract down. So essentially, what you want to do is break up this number into digits. So 1, 0, 2, 6, 3. I'll do it with each digit separately. So for the 1, so what you want to do for all but the rightmost digit is subtract that digit from 9. So this is not the rightmost digit, so subtract from 9. Next digit, this is not the rightmost digit, so subtract from 9. Good thing I caught that. This is also not the rightmost digit, so I want to subtract from 9. This is also not the rightmost digit, so I want to subtract from 9. Hey, this is the rightmost digit. What do we do on the last rightmost digit? Well, on the rightmost digit, we subtract the rightmost digit from 10 rather than 9. So we get 7. So this 89,737 is the tens complement of 10,263. Feel free to check that on your calculator. Oh, you shouldn't have one. Just kidding. Let me give you another number, and with it I'll show you another way to approach the same thing. I'll tell you another way to subtract numbers with this tens complement idea. So let's say you want to subtract from 100,000 the number 98,567. You ask, whoa, that's a messy subtraction. Yeah, I agree. It's messy. So, here's what we're going to do instead. See, notice that this is a higher power of 10 than this. It's the next higher power. So the answer should be the tens complement, right? But here's what I'm going to do instead. Instead of just finding the tens complement straight out, here's what I'm going to do. I'm going to just take the 98,567. Separate it into digits. Separate that out into its digits. I'm going to pad a 0 under the end. Okay? I'm going to pad a 0 onto the end. Next, now I'm going to start the tens complement procedure with 0.98567. So 9, 9, 9, 9, 9, 10. I'm going to do all these mini subtractions. So I get 9, 0, 1, 4, 3, 3. 901,433, and that happens to be the difference between 100,000 and 98,567, which is what we originally wanted to find. So that's a way you can use tens complements to find differences between a power of 10 and a number less than said power of 10. So I'm going to leave you with a couple of examples of problems, per se, that you should do, and you'll find the answers in a later post. Probably tomorrow or the day after. We're finding the tens complement of numbers that are large and have multiple zeros. For example, instead of finding the tens complement of 89, as in earlier, let's say I want to find the tens complement of 89,000. What's the difference? One's multiplied by 1,000, one isn't. But that's exactly it. What we can actually do is we want to find the distance to the next highest power of 10, which is 100,000. That's the next highest power of 10. So see, you know how they both have these 3 zeros? Well, you can just get rid of them. In this case, if they both have the same number of zeros on the end, you just get rid of them, and then you just have 189. Hey, we did that earlier. We found the tens complement of 89, which was the distance from 89 to 100. Yeah, it's 11. But that's not the distance from 89,000 to 100,000. That's the distance from 89,000 to 89,011. So, you guessed it, we're adding the zeros back. Hey, that is the distance from 89,000 to 100,000. It's 11,000. So, let me describe the general pattern to you. If you have a number, say 95,000, okay? Yeah, that's too easy actually. I'll give you a weirder one. 57,500. Okay? You count the number of trailing zeros. These are trailing zeros. So you got 2 of them. So let's assign a variable to it. N equals 2. N is the number of trailing zeros. Okay? So now, the next largest power of 10 is 100,000. Take the same number of zeros off of that number. Now, what you want to do is find the tens complement of the number that you get when you remove the trailing zeros. And the note about removing trailing zeros, if, say, you had, you have to remove, you remove a certain number here. If you remove a certain number of zeros in the actual number, you have to remove the same number of zeros up here in the next highest power of 10, otherwise it doesn't work. Anyway, so if you have 575, in this case, you derive that by removing the trailing zeros of 57,500. Find the tens complement of that, where the next highest power is not 100,000, but just 1,000. So the next highest power of 10 would be 9 minus 5 is 4, 9 minus 7 is 2, 10 minus 5 is 5, as I detailed in the last video. That's the tens complement of 575. Now, just add those two then just add n zeros back onto the end. That's the tens complement of the original number, 57,500. Is 42,500. You can check that by doing this over and whatever. Anyway, I'm Vrinchi from VedicMathsForKids.wordpress.com, signing out. Thank you and bye-bye.